The curious case of question 13 in the NCEES practice exam. In other ExOverZero videos, the focus has been on step-by-step solution procedures. This video will show how critical thought may not always work. Before continuing with this video, read question number 13 from your copy of the practice exam. This question is an example of you either know it or you don't. If you were to look up any or all of the key terms in the NCEES Mechanical Reference Handbook, you won't find any useful help to solve it. And remember, the reference handbook will be the only source of help you'll have on exam day. To quote from the handbook's preface, "The PE Mechanical Reference Handbook does not contain all the information required to answer every question on the exam. Theories, conversions, formulas, and definitions that examinees are expected to know have not been included. You should expect to have questions with content you will not be able to look up. Some things you're just going to have to know on test day. This reality should be instructive about your testing tactics. If you are confronted with a question that makes you want to look into the reference handbook, you should only give yourself a short time to find what you are looking for. If you look and don't find, don't keep looking and looking. If you do, you're only wasting valuable time. Remember, all PE questions should take an average of 6 minutes to answer. You could easily spend that amount of time looking in the reference handbook for something that simply isn't there. A mature tester should recognize that if they are lost on a question and can't find help in the reference handbook, they should give up and move on. But to do that requires self-confidence in your ability to search the reference handbook effectively so that you know you've searched well and it's just not in there. And there's only one way to get that confidence: to do lots of drills searching for things in the reference handbook. Also, the handbook will change. Here is a quote from the preface. "The PDF version of the PE Mechanical Reference Handbook that you use on exam day will be very similar to this one. However, NCEES will periodically revise and update the handbook, and each PE mechanical exam will be administered using the version of the handbook in effect on the date the exam is given. This means you must get good at the act of searching in the handbook, no matter what information you are searching for, and no matter if the content has changed from what you were practicing searching in. This can only be done by doing lots and lots of repetitions, searching all sorts of various things in the handbook. The only available tool for study is the ExOverZero reference drill book, available in the link below. On to the specifics of question 13 and the way it can be answered. Initial critical thought solution elements. 1. What are you solving for? The pressure drop at a specific point in a hydronic cooling system. 2. What is the fundamental process? Parallel and variable flow through piped control valves and cooling coils. 3. What are the first considerations to find the solution in connection to the fundamental process? Where the measurement is taking place within the system. And pressure versus flow in parallel fluid systems. 4. Are there key assumptions? The question will contain useless and misleading information, and the pressure and head changes for locations and equipment outside of the point being measured are insignificant. The concepts surrounding series versus parallel operations must be understood before you can enter the PE on exam day. There's not much critical thought you can use, and even less to look up in the reference handbook to help you in the test. It is fundamental to pumps, fans, and circuits of all sorts. This is a piping circuit in parallel operation. There are all sorts of YouTube videos you can watch on series versus parallel, and you can read about it in ASHRAE HVAC Systems and Equipment, Chapter 13, Section 2.4, Piping Circuits, and Figure 21. A really shorthand way to think about it is, for series circuits, flow is constant, while pressure changes or adds up. For parallel circuits, pressure is constant, while flow changes or adds up. You can check this in the Operating Conditions for Parallel Operation chart in the NCEES Mechanical Reference Handbook, found on page 234 of version 1.1. So in this instance, the circuit has parallel operation. You know that you don't add the pressure drops. Judging one AHU pressure drop and one control valve pressure drop is what you need to do. Also notice, right from the start, the question states that the system is variable flow. This is what you can expect given what you should know about series versus parallel. This simplifies things dramatically. Instead of worrying about 3 AHUs and 4 control valves, you just have to focus on one of each. That one of each idea helps you answer the critical question of where is the measurement taking place. The question says the pressure differential you are looking for is in between the chilled water supply and the return headers. These are the vertical lines in the schematic. To understand this better, you must understand another concept that you won't be able to look up in the reference handbook: source versus load. The source is the device heating or cooling the flowing fluid, which is the chiller, and it is cooling in this case. The load is the device using the heated or cooled fluid to condition the space, which is the AHU in this case. Study up on this in ASHRAE HVAC Systems and Equipment, Chapter 13, Figure 1, and Section 2.2, Thermal Components. The supply comes from the chiller and goes to the AHU. The return comes from the AHU and goes to the chiller. Now, what exists between those two vertical lines? A bypass leg of the circuit and an AHU, which is called the load. The bypass operation is controlled by, you guessed it, a control valve. This is a two-way control valve by the way it is drawn on the schematic. Again, you will not get any help from the NCEES Mechanical Reference Handbook about the different configuration of control valves for bypasses in a circuit connecting source and load. Suffice it to say, there are plenty of variables which include three-way valves: variable flow, variable temperature, mixing, diverting, etc. Study up on this. Again, go to ASHRAE HVAC Systems and Equipment Chapter 13, which is the definitive explanation on these sorts of things, and read Section 2.5, especially around Figures 22 and 23. It is in this section of the ASHRAE you will read two sentences which encapsulate the whole theme of this video. To quote, "General pressure drops are commonly applied to valve sizing. Values chosen roughly correspond to the pressure loss on a coil, although there is no literature to explain why these values are used." How's that for critical thought? To state it again, you just gotta know this stuff. The coil load is the thing the AHU is demanding to cool the air it is handling. And it is the thing the chiller is sending the chilled water to. So, you have one valve on the bypass leg, which must, at a minimum, accommodate the pressure loss of the coil in the AHU which it bypasses. That is, it must have design flow capacity to take on the pressure drop of the load, plus the pressure drop of the valve itself. The question requires the answer to be in PSI, so all head values must be converted to PSI. The question gives the valve pressure drop as 5 psi. The load data of the AHU gives a pressure drop in head, which you need to convert to psi. Add the two values together, and that's the answer. While it's not ideal to explain a solution with statements like, "You just gotta know this," remember, the PE is not a test that only requires critical thought. It also tests your background knowledge as a professional engineer with years of on-the-job experience. It tests what professionals should know, not just how good they are at critical thought. So, this question isn't a bad question, and the real step-by-step solution is work in the HVAC industry for years. If you fulfill the prerequisites to take the test, and if you're a practicing expert, you should know this.